Hello everybody, I hope you're doing well and welcome to the platform of CodeChef. Okay, so today we're going to be solving the problem binary matrix. The difficulty level for this problem is simple and the prerequisites require your basic bitwise operations. So this is your educator Ansh and I hope you like my video. Let's proceed to the problem statement. Okay, now let us try to understand the problem statement. So Shahid's friend has given him a problem to solve but is busy with his final exam. So he asked you to solve the problem. Problem is that you have given an n-cross-n matrix containing only zeros and ones. Your task is to AND every element of the matrix with the elements of its corresponding row and column and output the resulting matrix. The problem is as straightforward as it can be. Basically, I'm given an n-cross-n matrix and for say cell I comma j, any particular cell I comma j, I have to find the bitwise AND of it along with the entire row and column. So I'll just demonstrate what that means in the sample test case. Firstly, let us discuss some properties of bitwise AND. So basically my 0 bitwise AND is 0, my 0 bitwise AND 1 is 1, sorry 0, my 1 bitwise 0 is 0 and my 1 and 1 is 1. So basically if both the bits are 1 then only my bitwise AND is 1. Otherwise for any other bit with 0 my bitwise AND is always 0. So this is the property of bitwise AND. Now let me discuss what the problem statement means. So for any particular row, say for 0 comma 0, just take this particular row. So I am taking this row and I am taking this column, sorry this column and this row, and then as you can see I contains 1 0, so the bitwise and of the entire 5 elements will be nothing but 0, because if there's presence of only at least 1 0, then the entire operation will become 0. Hence for this particular operation the answer is 0. Now for my this particular cell, I have this particular grid which is my 1 1 1 and this particular grid, and again due to the 0 this operation will turn out to be 0, and so on my third will be also turn out to 0, right? Now for my this operation I have my this particular column and this particular row, and as you can see my all are ones in those things. So the answer for this particular cell is 1. Similarly for this cell all are ones and here also all are ones. So basically the answer here is also 1. Then for this cell my here it is 1, but here as you can see I have this 0. So due to this 0 the answer becomes 0 for this particular cell. Then for this cell, here all are ones and here also all are ones. So here it is 1 as my answer, right? Now for this cell, as you can see, here also all are ones, here also all are ones in my row as well as column, and hence the answer is 1. And in my last cell, due to the 0 of that particular column, my answer becomes 0. So yeah, the bitwise AND is quite simple, right? Okay, now how will I approach this particular problem? So the approach for this problem can be quite simple. What we can do is we can just simply initialize firstly a row vector of n length with all values as false. So basically a false vector of n length. So I'm just writing in this format. That means an array with all the values initially as false, that is of n length. Similarly, I can initialize my column vector with all values as false, which is currently of n length, right? So that is the idea. Now what we can do is, as you know, when I'm taking my matrix as input, any element say a I comma a j represents that this element lies in this row and this column. So what we can do is, if any of the element is say 0, I know that is gonna affect my entire row. So what we'll do is, for this particular element say I, if this element is 0, so if my this particular element is 0, then I know that my ith row, the all elements that will get influenced by that particular row will be 0. So I'll initialize my row of I as true, denoting that my this particular row will contain, or whichever element is influenced by this row, all will contain their elements as 0, because this cell has dominated 0, right, as we discussed in the example. Similarly, since my j column will affect it, so I'll just initialize my column of j also as true, denoting that this particular column is also affected by this particular cell. So yeah, we can do this for the entire matrix. What we can do is we can just simply take input for each and every cell, and if that particular cell is 0, I can simply mark my row of I as true and column of j as true. And then while again traversing in the matrix, if the row of I is true or my column of j is true for that particular cell while I'm traversing in the matrix. So for my I is equals to n, or for my I in range n, or for my j in range also n, if the row and column of that cell or both of the case is particularly true, then that signifies that in this row there exists at least one zero element, or in this column there exists at least one zero element, and due to that the bitwise AND of the entire operation will be nothing but 0. So if any of this condition is true, we can initialize the answer for that case or for that particular row to be 0, otherwise we can initialize the answer to be 1. So this becomes the approach to solve this particular problem. Now let's see how we can code this particular approach. Okay, now let's try to understand the code for the following problem. So here I entered all my header files necessary. Then in the main function, I initialized my fast input output so that I could reduce the time for running, right? Then for my t-test cases, I just simply initialized my n and took input according to the input format. Then I initialized my vector of row and column as I discussed in the approach section, and with all the values as false, right? Then for my num, what I can do is I can simply traverse in the matrix and I can input the element, and that if that element is 0 as I discussed in the approach section, I'll initialize the row corresponding to that element as true, and column corresponding to that element is also true, because that element will dominate the row for the final matrix that we are printing, right? And then I traverse in the following loop again, and then what I do is for any element I check whether this row contains at least one zero, or whether this column contains at least one zero, and if it contains, then bitwise AND for the entire operation will be 0. So I print 0, otherwise the bitwise AND will be 1. So exactly as we discussed in the approach section. And yeah, this becomes the code for solving this problem. Now let us run our code on the sample test cases to understand whether everything is working correctly or not. As you can see, we got the exact answer required in the sample test cases. Now let us run our code on the actual test cases to see whether everything works accordingly or not. Okay, so as you can see, we got the correct answer for the following problem, and yes, this becomes a valid approach to solve this particular problem. Okay, now let us see one of the solutions that got a time limit exceeded error. So why this particular individual got a time limit exceeded error is because he wrote the code in big of n cube complexity. So basically for my nested loop, again he traversed for the n size. As you can see, our time complexity of code is quite simple, which is big O of n square. And according to the constraints, it can easily pass for the test cases. Whereas this person wrote the complexity of big O of n cube. So although the solution might be correct, then because of the time complexity, he'll get a time limit exceeded error. So please don't make such kind of mistakes. Kindly look at the solution before doing this particular problem. Or kindly look at the constraints carefully before printing the solution or before writing the solution, right? So yeah, this is the learning you get from this video. I hope you like my video. Please like, share and subscribe to our channel. Thank you.